Have you ever wondered what exactly is an eclipse and why it holds such a fascination for us? Let's delve into the captivating world of eclipses, a cosmic ballet that has been performed across the celestial stage for eons. An eclipse in its simplest form is a dance of shadows, a spectacle created when one celestial body obscures another. There are two key players in this grand performance, the sun and the moon. The third player, our Earth, is the stage where this cosmic drama unfolds. Let's start with a solar eclipse, a marvel that occurs when the moon positions itself between the sun and the Earth, casting a shadow that turns day into a transient night. The moon, although significantly smaller than the sun, appears the same size from our perspective on Earth due to its proximity. This perfect alignment is a testament to the precision of our universe's workings. On the other side of the coin, we have the lunar eclipse. This celestial event happens when the Earth comes between the sun and the moon, casting its own shadow onto the moon. This results in the moon taking on a range of hues, from a subtle grey to a dramatic blood red, depending on the Earth's atmospheric conditions. But eclipses are not just a recent fascination. They've been a part of human culture and history for thousands of years. The earliest known records of eclipses date back to ancient civilizations. In China, for instance, the earliest eclipse record dates back to 2100 BC, inscribed on oracle bones. The Babylonians too were avid eclipse watchers, and their records date back to the 18th century BC. These ancient societies viewed eclipses with awe and trepidation, often associating them with omens or divine intervention. Today we understand the science behind them, yet their magic remains undiminished. So eclipses are not just spectacular events, but have been a part of human history and culture for thousands of years. How did our ancestors perceive these mysterious celestial events? In the tapestry of time, the human perception of eclipses has been woven with threads of awe, fear, and reverence. Long before the advent of modern science, our ancestors looked up at the darkened skies, their hearts pounding in their chests as they witnessed the sun or the moon being devoured by an unseen cosmic beast. In many ancient cultures, eclipses were seen as omens or signs from the gods. The ancient Chinese, for instance, believed that a dragon was swallowing the sun during a solar eclipse, and they would bang pots and pans together to scare the beast away. Similarly, the Vikings imagined wolves were chasing and eventually catching the sun or the moon. The ancient Greeks, however, had a slightly different perspective. Eclipses were still seen as portents, but they also sparked the curiosity of some of the world's earliest philosophers and scientists. Among them was Thales of Miletus, a renowned thinker of the 6th century BC. Thales is often credited with accurately predicting a solar eclipse that occurred in 585 BC. It's said that he used his knowledge of astronomy and mathematics to predict this event, a feat that must have seemed nothing short of miraculous at the time. This event is significant as it marked one of the first steps towards understanding these celestial phenomena scientifically, instead of attributing them solely to divine intervention. In the Americas, the indigenous people had their own interpretations. The Pomo, an indigenous group in the northwestern United States, told a story of a bear who started a fight with the sun and took a bite out of it. In response, the sun threw ashes on the bear, turning its fur black. As we can see, interpretations of eclipses varied widely, reflecting the rich diversity of human cultures and their unique cosmologies. But one common thread runs through all these stories, a sense of awe and respect for the grandeur of the universe. Eclipses were more than just astronomical phenomena to our ancestors, they were deeply significant cultural events. But how exactly does an eclipse work? What's happening in the cosmos when the sun or the moon disappear? To understand this celestial phenomenon, we must first acquaint ourselves with the science of shadows. When light encounters an opaque object, it creates a shadow. In the context of an eclipse, our celestial bodies, the sun, the moon, and the earth, are the players, and light from the sun is the source. Now onto the types of eclipses. A partial eclipse occurs when the sun and moon are not perfectly aligned, and only a part of the sun is obscured. Then we have total eclipses, where the moon perfectly aligns with the sun, completely obscuring it. But this can only occur when the moon is at a particular point in its orbit closest to Earth. In contrast, an annular eclipse results when the moon is farther away in its elliptical orbit, causing it to appear smaller and not entirely cover the sun. This results in a brilliant ring of sunlight, also known as the Ring of Fire. But what about these shadows we speak of? The umbra and penumbra are two types of shadows that come into play during an eclipse. The umbra is the innermost and darkest part of a shadow, where the light source is completely blocked by the occluding body. If you're standing within the umbra during an eclipse, you'll witness a total eclipse. The penumbra, on the other hand, is the shadow's outer part, where the light source is only partially blocked. If you're within the penumbra during an eclipse, you'll see only a partial eclipse. It's all a matter of perspective, really. So, in essence, an eclipse is a cosmic dance of celestial bodies and shadows. It's a spectacle of alignment and light, a testament to the precision of our universe's mechanics. Eclipses are truly wonders of the cosmos, a perfect alignment of celestial bodies. So how do we view eclipses today in our modern, scientifically enlightened age? Eclipses are no longer the harbingers of doom or divine messages they once were. Rather, they have become valuable tools for scientific discovery and sources of unbridled fascination. With our advanced technology and scientific understanding, we now decode the mysteries of these celestial events and use them to further our knowledge of the universe. Take, for instance, the total solar eclipse of 1919. It was during this event that British astronomer Sir Arthur Eddington confirmed Albert Einstein's theory of general relativity. By observing the stars near the Sun during the eclipse, Eddington demonstrated that light does indeed bend around massive objects, just as Einstein had predicted. Without the unique conditions provided by an eclipse, this monumental scientific discovery may have taken much longer to confirm. But eclipses are not just for the scientists. They've also given rise to a unique subculture: eclipse chasing. These are individuals, often amateur astronomers or simply nature enthusiasts, who travel the globe to witness these awe-inspiring events. For them, standing in the moon's shadow, experiencing the sudden drop in temperature and seeing the sky darken in the middle of the day is an experience like no other. They will often go to great lengths and travel vast distances to stand under the path of totality, where the effects of an eclipse are most pronounced. And why wouldn't they? Eclipses offer us a rare opportunity to witness the cosmic ballet in its most dramatic form. They remind us of our place in the universe and our connection to the celestial bodies that dance across the sky. So, whether we're validating groundbreaking theories or simply appreciating the astounding beauty of the cosmos, eclipses in the modern age continue to play a significant role. They are more than just celestial phenomena. They are a testament to our insatiable curiosity and our enduring sense of wonder. Today, eclipses continue to captivate us, both for their scientific value and their sheer beauty. So what's next for our understanding and appreciation of eclipses? As we move forward into the future, there are a number of notable eclipses on the horizon. For instance, in August of 2027, we can look forward to a total solar eclipse that will be visible across parts of North Africa and the Middle East. This event is expected to last a staggering 6 minutes and 23 seconds at its maximum, which will be the longest duration of totality in the 21st century. But it's not just about watching and waiting for these cosmic events. The science of predicting and observing eclipses is also advancing rapidly. Modern algorithms and supercomputers have made it possible to predict eclipses with unprecedented accuracy. And the advent of satellite technology has opened up new possibilities for observing these events from unique vantage points. Imagine viewing an eclipse from the International Space Station. Astronauts have already experienced this extraordinary sight, watching the moon's shadow race across the Earth at over 1,000 miles per hour. And as commercial space travel becomes more commonplace, more people may have the opportunity to witness this breathtaking spectacle. But why stop at Earth? As our exploration of the solar system continues, we may one day witness eclipses from other planets. Mars, for example, experiences solar eclipses when its moon Phobos passes in front of the Sun. Though these events are brief and Phobos only partially obscures the Sun due to its small size, the sight of an alien eclipse could be truly awe-inspiring. With each passing year, our understanding and appreciation of eclipses continue to grow. We're not just passive observers anymore, we're active participants in a cosmic ballet that's been unfolding for billions of years. And as we continue to push the boundaries of our knowledge and experience, we're discovering new ways to interact with and learn from these celestial events. As we continue to explore the cosmos, who knows what new perspectives on eclipses we might discover?